हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। फ्रेंड्स, आइए स्टार्ट करते हैं दिस न्यू चैप्टर, एयर रेफ्रिजरेशन सिस्टम। फ्रेंड्स, इन दिस we will see the bell-coleman cycle or reverse Brayton cycle or reversed Joule cycle. So air refrigeration cycle work on bell-coleman cycle or reverse Brayton cycle or reversed Joule cycle. Okay, so in air refrigeration system, air is used as the working fluid or refrigerant. It means air we will take, and by the air the heat is removed. Okay, so air is working as a refrigerant in the air refrigeration system. Getting, friends? Air refrigeration cycle is used in aircraft refrigeration system. So whatever our aircraft is there, aeroplane is there, in that air refrigeration cycle is used, and in this air is used as a refrigerant. Why? Because of its low weight per ton of the refrigeration. So per ton of the refrigeration, because of the air, the weight is less. Okay, because air we can take from the environment and we can cool the system, then we can reject in the environment. Okay, so no extra refrigerant is required to carry. So because of this, what happened? Low weight per ton of refrigeration achieved. Getting, friends? Now friends, we will see the bell-coleman cycle or reverse Brayton cycle or reverse Joule cycle. It is working on this circuit. So in this, friends, this is the compressor, this is the cooler, this is the expander, and this is the refrigerator. So what happened, friends? Process 1 to 2 is done in the compressor. What compressor will do? Compressor compress the air and it will pass through the cooler where it will reject the heat. So here heat rejection is there. Then again it will pass through the expander where the temperature of the air will be very cool. Okay, so again after the expander, when it will pass to the refrigerator, then it will carry the heat from the refrigerator. So here in this process, heat addition is there, or we can say Q addition is there, heat addition is there. Then again this air will pass to the compressor and then it will pass to the cooler. Getting, friends? So process 1 to 2 is isentropic process in compressor. Process 2 to 3 is the constant pressure heat rejection in the cooler. Okay, constant pressure heat rejection in the cooler, because here the heat rejection will be there. Now in process 3 to 4, it is isentropic expansion. Because of the expansion in the expander, the temperature of the air will go down. So what happened? It is ready to take the heat, or it is ready to take or absorb the heat from the refrigerator. So process 4 to 1, constant pressure heat addition in the refrigerator, because the cool air which is coming from the expander, it will pass to the refrigerator, and then what happen? It will absorb the heat from the refrigerator and it will again pass through the compressor. Getting, friends? So now you can see this one on the TS diagram and PV diagram. So friends, this is the TS diagram, temperature versus entropy diagram. Process 1 to 2 is in the compressor and it is the isentropic process. So PV to the power gamma is equal to constant. So here the entropy S1 is equal to S2 because it is constant, or you can say isentropic process. Okay, process 2 to 3 is the constant pressure heat rejection process. So in this case, what happened? Heat rejection is there in the cooler section. Then it will pass through the expander by the isentropic process, PV to the power gamma is equal to constant, and because of this what happened, the temperature will reduce. Okay, the temperature and pressure will reduce, then again it will pass through the refrigerator, where what happened, it will absorb the heat. So heat addition is there in the refrigerator, then again it will pass through the compressor, and this cycle will continue. Okay, similar case in PV diagram, just understand, this is the pressure, this is the volume. So pressure versus volume diagram, process 1 to 2 is in the compressor, and it will follow isentropic process, PV to the power gamma is equal to constant, and the process is coming like this. Then 2 to 3, as I told you, that the pressure is constant. So at constant pressure, what happened, heat rejection is there. So here heat rejection will be there in the cooler section. Again, when it will pass through the expander or in process 3 to 4, what happened, the pressure and temperature will reduce. Okay, and it will follow the isentropic process, PV to the power gamma is equal to constant. Okay, then at lower pressure it will pass to the refrigerator, where what happened, it will absorb heat. So here heat addition is there, here in this section heat addition is there, then again it will pass through the compressor. So this is the TS diagram and this is the PV diagram. Just learn how to draw this one. Okay, so friends, as we know that what is the air refrigeration cycle or bell-coleman cycle or reverse Brayton cycle and Joule cycle, in this we seen TS diagram and the cycle, this compressor, cooler, expander and refrigeration cycle, refrigerator. So फ्रेंड्स, आपको किसी भी पॉइंट पर डाउट हो, आप मुझे कमेंट बॉक्स में पूछ सकते हैं, मैं उसका आंसर देने की पूरी कोशिश करूंगा। फ्रेंड्स, मेरा एक्सप्लेनेशन अच्छा लगे तो प्लीज़ लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए फ्रेंड्स। थैंक यू।